morning, everyone. We have three very interesting talks this morning about ATAM, about quality attributes. I'm a certified ATAM evaluator myself, and I know the importance of quality attributes and the same trade-off, so I'm very much interested in what they have to say. And the first talk is the tale of three ATAMs by Andrzej Knafel from Roche Diagnostics in Switzerland. So, Andrzej.
Hello, welcome, good morning. I hope you can hear me. So, Roche Diagnostics, just for your short information, is a medical device company developing and manufacturing the chemistry, consumables, reagents, the instrumentation, and the software. And I will talk to you today about three ATAMs on the same project, which is kind of like why we did it on the same project and what the project was and how it influenced our organizational and architectural decisions. So because it's a tale, it's a story tale, so we start with some prologue, and I will paint you the scenery and the actors, and then we go through three acts, like in a good theater play. One of the ATAM of the old system, another of the reference architecture, implementation architecture, and at the end, some epilogue with conclusions. So let's imagine this scenario. Let's imagine we have business applications, the green boxes up there, which are in our enterprise, and they are communicating, they are producing or consuming data and communicating with devices which are located in laboratories, hospitals, pharmacies, general practitioner office worldwide. So not sitting in our environment. This is the general standard. What are the devices, the actors there? There can be small, like in comparison with the person, there is more or less the correct size. They can be tabletop devices. They can be standalone big boxes like, a keyboard. And they can be also fully automated laboratories which would just not fit in the room. So there is a lot of modules, like but you see by comparison with the person, which are processing thousands or 10,000 results per hour. So there are our devices. And so that you see what is the characteristic of the devices, I mentioned they are located worldwide, which has some consequences. The consequence one is that we are underlying different medical device regulations, and second, also different privacy and security regulations. Additional complexity here is these devices are not in our Roche environment. They are located in hospitals, in pharmacies, in other environments which have various maturity aspects worldwide. So to see the size also of the problem or the challenge here was we have the devices which we're targeting to connect are measured in millions. And the volume of the data exchange daily for, let's say, 90% of the devices are like individual megabytes per day. For around 10% of the devices, the bigger ones, is going in gigabytes per day. So this is our challenge. Now, what are the use cases usually? First of all, the devices need to be registered and configured. Registered means they need to be authenticated towards the infrastructure and obviously the infrastructure towards the devices. Second, we are transferring data from the business applications which are up to the device which are down there. Therefore, we call it download. We are transferring their processing parameters, which is the data accompanying the chemistry, the reagents which are running on the devices, and obviously also software updates and upgrades. We are transferring data from the devices to Roche Enterprise, which are like alerts, events, operational counters, log files, raw measurements, and so on. And we have also cases when some diagnostic tools or screen sharing, our call center, service call center, wants to interact with the devices in whatever service case. This is the general scenario, the stage. Now, I will walk you through the play, starting with historical information about what we had at the beginning, the homegrown and commercial system, why and how we did the ATAM 1 and the architecture improvement workshop. And by the way, I assume that people who are visiting SAE conference are aware that ATAM is architecture trade-off analysis method and AIW is architecture improvement workshop. If you are not, I refer you to SAE website and their training materials. After this Act 1, we will go through how we came to the ATAM second review. for the reference architecture, and later how we used all this information from all these reviews into assessing the implementation architecture within the ATAM 3. So we did 3 ATAMs on one pretty complex project. And at the end, what are the conclusions for us? So this is the play. The history here, the prologue. Before the IoT, as the abbreviation was invented, Roche was connecting devices. We started connecting devices year 2000. And our devices are, as I mentioned, a little bit more complex than simple sensors. They are rather systems. We developed homegrown system until 2007, and since then we didn't touch any line of code on this system. Still is operational under load which is 7 times higher than the original specifications. Year 2008, our management decided, well, we will not invest in the homegrown system, we are buying one. So, and then within 6 years, we didn't roll out 25% of the functionality. Now, and in parallel, obviously, the market changed, so we are growing number of systems to be connected, new use case which increases the load of data, and some additional more demanding quality attributes like performance, security, and so on. So then we were called, the architects, hey, can you guys help us roll out the system? So this was the original question. After looking at it for a few weeks, we said, oh, we need to, this is politically hot potato. We need to get here very structured process and get external party, which was in this case SEI, helping us to, with the structure ATAM process, assess where we are. So that's the start of the Act 2, ATAM of the old existing system. Well, when we did this ATAM, and I'm not going into the details of the process here, we ended with, there are the, just summary of the quality attributes which are imported for us, and you see some of them, the red ones were just, equipped with big risks. There was the availability and reliability, and it was, not addressed properly by the commercial system. Performance and scalability was not addressed by both systems, and the old system, the homegrown, was definitely not modifiable or extensible. Actually, we have still one person here, is 73 years old, who is still the only one person who is maintaining the code there, to some extent. Yeah. In general, we just had the concern as an organization that we are not being able to fulfill the business needs, the growing business needs, and obviously the customer expectations. So after this first ATAM, like the next step, we did the architecture improvement workshop. What was the outcome of this? Well, we are lacking some organization, like for example, governing the architecture. So we recommended changes in the organization. There were improvement recommendations for the existing systems architecture as far as possible. And also, well, can we look for some alternatives? Now, we also, what is important, we decided, okay, we are just actually happy with the ATAM review process, mostly because of the acceptance of the structure by management and so on. We will use it later in the process too. Now we are entering the Act 2, the ATAM of the reference architecture. But first, see what happened with the improvements. Well, we could, just by not changing the code, by distribution of the database differently among various storage, let's say hard disks, we could reach that the old homegrown system can handle load 18 times higher than the original specification, which expanded our window for the decisions. This was the successful part. Unfortunately, we didn't resolve the risk and limitation of the commercial system. We still, after 3 or 4 months, we say, well, there is practically zero chance that after 6 years plus this exercise, we will be able to roll out the system. Therefore, there was high importance of searching for alternative solutions. And this is how we approach this. Learning from this ATAM 1, we said, okay, now let's develop a reference architecture which first fix this risk, which does not demonstrate this risk which were observed in the original system. So we used patterns. I don't go into details. We obviously don't have time for this. I have this afternoon business or office hours, whatever it's called, just if you are interested in details. But there was something like command response behavior with sender-controlled, time-constrained, multi-level acknowledgement. Sounds mouthful, but it is one of the reliability patterns which we used. The reference architecture, we decided specifically be technology agnostic because we used it or intended to use it at this point in time in the solution and vendors evaluation. Additionally, we established the architecture governance organization, and it was focused mostly on the interfaces. We assume that because this can be different technology, we just want to box it so that all the interfaces and cross-cutting concerns are really governed, that even if we decide to throw out or replace some point in the future, the multi-million box will not affect this 10 to 20 business applications, the green boxes up there, which are using this infrastructure. And we did the ATAM 2 of the reference architecture. As you can see, the risks were acceptable for our organization. We had some trade-offs, but they were acceptable. However, what we could have anticipated, and well, we just maybe didn't at this point in time, that doing an ATAM of a reference architecture automatically says, well, the decisions, architectural decisions are top level, high level. So there is not maybe enough details in this, well, not being yet implementation architecture. Additionally, because we were using this reference architecture for evaluation of service and solution providers, we had some potential risks of how we are managing this, how we are managing these solution providers. Obviously, this risk generated some improvements potential. And what we try to do is, well, okay, let's go on it one by one. And this is the point of which I will make also repeat at the end. ATAM enables a very targeted reaction to some of these risks. And here was the, okay, we need to specify the interface in detail. We need to stabilize more in detail the reference architecture. We defined the proof of concept to confirm that our top-level decisions will be really working in practice. And we continue on the service and solution provider selection because it's, the selection usually goes less a funnel and you end with hopefully one partner, but just you are narrowing the selection. One important point was that we defined the required SLAs. I will talk about it in the next slide, why it's important. Just remember this one, it's your SLAs are important before you go to the discussion and negotiations with your partner. We sent to the pre-selected candidates the quality attributes, including the scenarios, the reference architecture, the required SLAs, and some commercial requirements which were not, authored by the architecture. We also prepared the evaluation criteria based on the what we learned from the ATAM reviews. And now we are slowly entering the implementation architecture. And during this phase now, we were architecting. So I will not be able to present you the entire architecture, but I selected few aspects, just because of the time, selected few aspects which may be interesting. Well, we at some point you say, well, maybe we should go with the cloud technology and cloud services. Why? Here is some of the rationalization why. For us, it's important to have, for example, the latency of the last mile pretty short. And this means that we, as a Roche, even if we have data centers in Europe and in North America, we are not able to go, let's say, to Brazil and have their data center, which means we are targeting these providers which would help us with their content delivery network or with edge nodes of the cloud. Second, we, since years, we are probably courageous and stupid at the same point in time to go with the public cloud technology fairly easily at the enterprise level, which means we have already various public clouds in our use. I don't want to mention the vendors, but which means that the green boxes, the business application, can be in the same cloud like the remote service, can be in a different cloud infrastructure, or can be obviously on premises, which well, needs to be carefully considered not only in terms of the functionality, but also in terms of price. As you probably know, egress of data from cloud can be expensive. The SLAs. Each of the cloud provider will give you, you can download it freely from their website, the SLAs for storage, for connectivity, for processing. Well, all our use cases have storage, connectivity, processing in various aspects. When you multiply the individual SLAs, maybe you don't get what you are hoping for. So therefore, this is very important. Get your SLAs, the required SLAs, before you go to the cloud provider with what they will offer you. And the fourth point of this was actually pretty interesting. This was one of the most selective points, eliminating a lot of the potential service providers. We are a global company. Our customers are worldwide. It's very difficult, even the major cloud providers, that they consider and have either data centers in, for example, Russia or China, or at minimum partnerships with data centers in Russia and China. Some of them just don't. So this is global availability is very selecting criteria for determining which provider you use. If you are, or if we were deciding developing something for cloud, well, obviously you can treat cloud as a collection of computers. Well, this has some, you can treat it this way, but you will not utilize it properly. In order to utilize cloud properly, you need to use some of the cloud design patterns and some of the best cloud practices. And there are, like, for example, health endpoint monitoring or even sourcing as patterns which are really good for cloud, or auto-scaling. And you need to define what is your unit of scale when you will deploy new unit of scale. And units of scale usually depends on the use case, which are usually a combination of some storage, some connectivity, some processing in our case. Next aspect of the architecting here, complex event processing. I selected on a few of them, but we had just discussed, people who were in the security session by Rick shortly before maybe noticed that we were discussing it too. We are receiving millions of events. The stream is very rich, and we don't want to pass all these events through the cloud to the business application. So we need to analyze them on the fly and somehow limit what is the relevant. I give you the first example, very simple one, heartbeat monitor. Because our devices can have only outgoing connection, this is what is generally permitted by the healthcare organizations, we need to have a heartbeat monitor for approximately 1 second. So, but when do you decide that your device is connected or not? There is not like you have heartbeat or you are dead. Some of them are like 2 heartbeat coming, 3 not. 1 coming, 4 not. 4 coming, 1 not. So the patterns are geographically dependent and device type dependent. You cannot make a general rule. You need to have a really analytical engine behind it to make this for even the simple heartbeat analytical processing. But there is obviously security is interesting point. So I'm not going through the details. If you want, we can discuss it maybe later. What I have mentioned, we decided also on proof of concept. And this was also interesting exercise. How we did it, we just had deployed the prototype of the infrastructure in cloud A and run 100,000 simulated devices from cloud B. Why not in the same cloud? Because the connectivity within the same cloud is usually so good that it will be just not the right result. So we had cloud vendor A, which was spinning, well, we didn't pay for the 100,000 virtual machines. We use 10 clients or 10 simulators per virtual machine, but still spinning 10,000 virtual machines within 12 minutes was a challenge for this very big cloud provider. And we just analyzed the major use cases with aspects of scalability and performance and reliability, and we actually were pretty happy with the results, because the quality attributes which we addressed with the proof of concept, all of them were confirmed and some of them were better than we expected. And we learned a lot from this exercise. So at the end of this, we had a lot of the input. We had the implementation architecture, because as you have seen some of the snippets we were architecting. So we went to the ATAM 3. And also we ended with the quality attributes, by the way, did not change. This project, it was, let's say, around nearly 2 years between the ATAM first and the ATAM 3. And the quality attributes did not change much within this. But obviously, we evaluated more and more scenarios with each of the ATAMs. And the risk landscape changed. Here, the risk is integration of the remote service in the Roche business processes and missing or incomplete operational concepts and some migration scenarios. So coming now to the conclusions. The first conclusion is, well, as I mentioned just in the last sentence, the risk characteristic is changing. The first one was serious technical deficiencies and organizational issues. This was for the old system. Second, well, the reference architecture. We had many unknowns, top-level decisions. We have potential risk of vendor management. The third one was, well, we have migration, operation, integration issues, but not any of the original risk. We could eliminate them or minimize them to a very acceptable level. Second, when you do multiple ATAMs, which probably few companies do, but multiple ATAMs permit you to build pretty well one decision on, let's say, fixing of some risk and going into the next one. So the planning from one ATAM to the next ATAM is relatively easy. As outcome of this exercise, and we did more than the 3 ATAMs within our company, we started viewing ATAM reviews as being integral part of our system engineering or system development. And the last one, which I think is very important for me, is the targeting of this. This is really what I have learned from this is that we can fairly easy, when you have the stakeholders in one room, which is one of the major difficulties of ATAMs to have the stakeholders in one room, but if you have them, you have a high acceptance of the targeted changes which you can do, and there are both organizational and technical changes here. So to make it short, for us, currently ATAM is used as an evaluation tool within the system development and influence also the organizational changes. And this is the experience which we made. So if you have any questions, either to the IoT architecture or to the ATAM, I'm at the end of the talk.
We have time for questions.
I think
I have a question.
probably need to use this, but I'm not sure if it is switched on.
Yeah, there we go. My question is, as you progressed from the old system through the various stages, did you find, when you got to the end, that your testing was more effective? And is this going to have an impact, the next time as you have more requirements churned?
Well, because this, yes and no. First of all, we just defined testing scenarios for example, the proof of concept. And by the way, we are not finished with the implementation yet, so we didn't test it yet. But related to the requirements this is one of the entire platform serving this million of devices is one of the component of the business processes. So you have the platform testing as a component, huge one, but you have also testing of the various business processes. And that is set up specifically so that we can obviously expand on business process, which we just don't know yet today. We will be facing some interfacing changes, therefore versioning of the interfaces, and this will need to be tested, and so on and so on. But specifically, some of the patterns, like the command response, when you can change the command semantics without, let's say, jeopardizing the backwards compatibility, were one of the conscious decisions here.
Two questions. First question is, when you did the analysis of the old system, you found out it could handle 18 times the original specification, which bought time to actually do the further study. Did you, as the architecture organization, have issues convincing the senior management and management to actually continue on the current path, or did they try to push this decision off to a later time?
Well, it would be, you are probably right, this would be the right direction. They were already relaxed when they heard it. But the 18 times the original specification still did not fulfill the target. So therefore, they say, OK, now we need to continue. But generally, this would be the natural reaction of a management.
OK. And the second question, after you did the ATAM 2, and you had other questions for the proof of concept, and you started doing the cloud-based proof of concept, did that help going into ATAM 3, having that proof of concept and realizing that a lot of your quality attributes you already met? So did that actually make the ATAM 3 easier than it would have been if you hadn't done the proof of concept?
Yes, that's what I mentioned. We wanted to have, after every ATAM, before we go into the next one, we wanted to fix the risk as much as possible from the previous one. And as you maybe remember, the ATAM 2 discovered the risk while the, let's say, ambiguous or maybe not concrete architecture decisions. And therefore, the proof of concept was to let's say, to find or document the answers that we made good decisions. And therefore, in the ATAM 3, we just said, OK, we dealt with this risk. There are the proof of concept results. They are more or less minimizing the risk which were in the ATAM 2, so we can focus on new ones. But as you have seen, the scenario number grows. So with each of the ATAMs, we looked at the scenarios from the previous ones and added new ones. So the proof of concept fixed some of the existing previous risks.
Any other questions?
So there were a lot of big decisions made and a lot of steps and moving parts. What did you use for documentation? Did you do any formal documentation, or how did you take care of that?
Well, OK. What I probably need to say, we are trained by SAI also on the documentation. Now, seriously, we have our own document standards on the software architecture documentation. We are from the medical device business. You are just required by the regulatory agencies, administration, to have a good documentation with traceability from everything, from risk assessment of security, risk assessment of product safety, up to the, up to whatever requirements and testing. So we have very complete documentation. For the ATAM specifically, we used for 2 of these ATAMs with the we ordered actually from say the official reports. And from the ones we said, OK, we can stay with the presentation. It is anyway 90-something slides, so it was enough detailed for us.
Hello.
Yeah, you can talk.
Hey, how did you prevent this from getting into like a waterfall-like model where you used ATAM when you came up with the reference architecture and implementation?
OK, so we, in general, what I probably should say about our process is because of the regulatory-driven process, our top milestones are waterfall. We are doing agile. We are Scrum company, so we are doing a lot of sprints, in the development phases and testing phases and even requirement sprints. However, we have like milestones which are really milestones, and then we are waterfall there.
All right, let's thank Andrew.
Thank you.